Metals mine quarry. Metals is a solid material and element compound that is typically hard, shiny, and with a good electrical or thermal conductivity. Metals are generally malleable, that it means that they can be harmed or pressed permanently out of shape without breaking them. Okay, the meaning of metals differs for various communities. For example, astronomers use the breaking term metal for convenience to collectively describe all elements other than hydrogen or uranium. In astronomy and physical cosmology, the metal is an object is in proportion in its matter made of chemical elements other than hydrogen or helium. In addition, many elements and compounds that are not normally classified as metals become metallic under high pressures. These are known as metallic allotropes or nonmetals.
Properties of metals. Chemical. Metals are usually inclined to form cation electron loose, reacting with oxygen in the air to form oxide over various timescales. The transition metal has lower oxides because to form passivating layers of oxide that protect the interior. Other like palladium, platinum, and gold don't react with the atmosphere at all. Physical. Metal in general have high electrical conductivity, high thermal conductivity, and high density. Typically, they are malleable and ductile, deforming under state with cleaving. In terms of optical properties, metals are shiny and lost.
Electrical. The electrical and thermal conductivity of metals originate from the fact that the air, oil, electrons are decollized. This situation can be visualized by seeing the atomic structure of a metal as a collection of atoms embedded in a sea of highly mobile electrons. The electrical conductivity as well as the electrons' contribution to the heat capacity and the heat conductivity of metals can be calculated from the free electrons model, which does not take into account the dilated structure of the ion lattice. Mechanical. Mechanical properties of metal include ductility, like their capacity of from plastic deformation. Reversible elastic deformation in metals can be described by Hooke's law from restoring force, where the stress is linearly proportional to the strain. Force larger than the elastic limit or heat may cause a permanent, irreversible deformation of the object, known as plastic deformation of plasticity. This irreversible change in atomic arrangement may occur as a result of the action of applied force or work and a change in a temperature, heat.
Extraction. Not ferrous metal are from minerals that can be found on the surface of the earth or in a surface reservoirs. In both cases, must be followed technical, efficient, and profitable operations, refined or concentrate as also known as preparations. Minerals which are obtained non-ferrous metals are never found in a pure state in a commercial quantities, so they must be separated and prepared. Among the process most commonly used is the preparation. You pulverize the ore and then mixed with water and oil for applying of form violet action in which metal are suspended forms. Then the foam and the wheat is the mineral necessary for productions of non-ferrous metals are removed. Fusion. More furnaces used for melting not ferrous metal ores are blast furnace and preparatory furnace. Although not all non-ferrous metal be melted, first need to be processed. In furnace for the production of non-ferrous metal are always equipment to control dust emission. More than a measure of air pollution control is most because the powders are valuable because they have the ore being processed, or because of these powders can be obtained other materials with a representative or profitable value. Tuned. To achieve the quality and purity characteristics needed in non-ferrous metals can be used as the electrolytic process different tubes with minerals acquires to very high levels of quality.
Now talking about the application of metals, uses in industry, as a corrosion protection for welding and related alloys, and in the manufacture of nickel-cadmium batteries, considered excellent for the safe operation. Metals that are intended for particular uses are antimony, cadmium, or lithium. Iron, for example, is a very abundant in natural formic metal oxides and other compounds. It's used for the manufacture of rules in the construction of buildings, bridges, and others. Other applications: development of tools, instruments, and components for civil buildings, ships, and automobiles. Resistant structures made of steel-shaped buildings, skyscrapers, and houses. Bridges, whether modern, pendants, bow, and others. Contemporary sculptures, sails, ships. The steel is stronger and harder than wrought iron, which is almost pure iron.